So let me start by one. Are there studies on these types of attacks and whether is this a primary vector of attack, or are there sort of stealing the main design document is a vector? Like, how does the threat rack and stack against other threats against IP when we are talking about manufacturing?
How is a threat?
How does this particular type of attack, optical side channel attack, compare with other threats to the intellectual property when we are talking about manufacturing? For example, stealing the design document.
Oh, okay. Yeah. So yeah, you can definitely try to steal the intellectual property directly by stealing the documents. You can even perform the attack. Just try to get into the computer system, right. Try to perform a traditional cyber attack. Try to just copy the data out from their from their additive manufacturing systems. But their threat mode is like this. So we assume that because we want to protect intellectual property, we assume that their system, they actually apply some of the most traditional security measures very well. It's just like side channel attacks that are more recent, more stealthy. For example, in 2016 there were 4 papers describing the possibility of using acoustic side channel attack to steal the intellectual property. But then before that, some of the major measures for protecting a computer system have already been in place. It's basically the threat model will assume that those things are already in place. It would be very hard to perform those traditional attacks. But if you can do those things, yeah, there's no need to do the side channel attack. We just assume that they don't know this kind of new methods to attack. Because for example, like in the Optical 3, right? It requires very strong authentication if you want to make any changes to the printer or try to copy anything out from the printer directly. But it doesn't require any authentication to see the video. Yeah.
Right. And is the defense that you studied, particularly the randomization one, is it specific to a type of additive manufacturing, or can it be applied to all of them, like 3D printing versus CNC machines versus other ones?
Yeah, it's actually a very good question. So this thing here, I think it not only applies to other types of manufacturing processes, if you want to do that, but also applies to the machine learning principles in general. So basically, we want to defeat this machine learning process, and we want to so you can see that for the existing methods right here, it's possible. Let me just show you really quick. Yeah. Sorry. Okay, so for some of the existing methods, even as a human being, you are able to tell the location of the real and the fake one, right? You can still recognize the thing very well, but for state randomization, you can see that even for human beings, it can be hard, right? So basically, we just try to exploit the limitation of the projector, try to push the limit, and think about some of the best way to disturb the process. Yeah.
Right. Great. Are there questions on Slack?
Yes, we have one question from Slack. Can an attacker make use of the correlation between subsequent frames in the video? In other words, does your technique infer the position one frame at a time, or by analyzing a sequence of frames that must show a connected set of physical positions of the print head?
Yeah, so it's also a very good question. So as you can see, so this is actually a basic let me just show this really quick. You have the print pass here, right? So yeah, there's definitely kind of a continuous process going on here. Maybe you can apply Kalman filter or try to exploit the time series connection between the points to try to enhance the attack. Definitely, that's something can be done. But the point here is that we are trying to in this attack, we don't apply that. We just try to perform the attack frame by frame independently. The idea is that for existing noise patterns, you can see that they actually you can already see the result details very well. You can even see the number of teeth in the gear. If you apply those advanced techniques further, it will be easier to see more details, right? But in this case, you cannot. It's actually there's enough noise to even disrupt some of the attacks. But that claim needs to be further substantiated by further experiments. Maybe for certain scenarios, you may be able to filter out some of the noise, but for this thing, I really doubt that you can do that. But that's a very good concern.
Yeah. So just one question, based on this image, is the attacker just trying to recognize what the object being printed is? Because it doesn't seem like these images here that would have been recovered are useful in any way. like it's still inaccurate, right? You wouldn't be able to print this and this would be operational, would it? There's still some sort of recovery process that needs to take place.
Okay, so yeah, so definitely, like, you can see even for the our state randomization method, the advanced attacker can still recover something, right? Maybe recognizes a key, but that's not enough. So if you have access to the video, right, you can probably see what is printed there, right? You can see the final results. But here the point is that you want to know the manufacturing process. If you don't follow the exact procedure, you're probably not going to have the same property of the object. Just like you try to counterfeit something, right? You can see a product there, but you don't know the manufacturing process. You're not going to have the same exact quality of the result. So here, like the intellectual property is not just about the general design, it's also about the manufacturing process, the quality, the final product. Yeah.
Is it quick one?
Hi, so I have a quick question. So as an attacker, the attacker monitors the head's movement, right? So as a defense mechanism, how effective would it be to just randomly move the head in some like vague fashion?
Yeah.
And then instead of having like a sophisticated projector which corrupts or like manipulates pixels, how effective would it be to just move the head randomly in the fashion?
Yeah, so actually, we look into that thing. It's called movement obfuscation. So you can see that you try to move randomly, right?
Yeah.
There are actually two problems with this approach. First of all, you're going to increase the printing time.
Yes,
That's actually a very big concern. Second, you have something called the stringing effect. You're going to degrade the quality of the object. So we want to make sure you have the same quality as a result. So our method doesn't affect the quality at all. So unless you're doing some optical sensitive printing processes like SLA, but for FDM or many other printing processes, we're good.
Okay, thank you.
Yeah.